Hello, everyone. Welcome to Cloud Operations 207. My name is Bobby Hallahan, and today I have my colleague with me, Justin Brown. Today we're going to be speaking to Inside Amazon Operations, how Amazon Alexa gains observability. A little bit about myself. I'm a senior specialist SA on the observability team here at AWS. Part of my time here, I've worked as a support engineer as well as a technical account manager, but most recently working as a specialist solutions architect with observability, focusing mostly on CloudWatch, X-Ray, as well as our managed open source offerings, such as the AWS distro for OpenTelemetry, Amazon managed Prometheus, as well as Amazon managed Grafana. I also have my colleague today, Justin, who's on the Amazon Alexa team, and I'll go ahead and let Justin introduce himself.
Thanks, Bobby. Hi, everyone. My name is Justin Brown. I'm a senior solutions architect with the Alexa Excellence team. I've been leading a number of operational cost efficiency, optimization, and observability initiatives over the past 3 years. And just to be clear, I'm much more excited to be here than this picture might indicate, so let's just call this my mentality before I learned everything we're going to cover today. Speaking of what we're going to cover today, Bobby, what's in the agenda?
Thank you, Justin. So let's talk about our agenda today. First, we'll start with an overview of observability. We'll then discuss how the Alexa team uses observability, and Justin will walk us through that journey that the Alexa team took with observability, specifically around operational excellence and then cost attribution, managing underutilized resources, functional efficiency, and then lastly, we'll cover a recent release to the CloudWatch service. So let's dive right into an overview on observability. First off, when we think of observability, we can always go back to where it was once originally defined in control theory. So observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. Now let's pause and think about that for a second. If we think of understanding the internal state of a system, think of a workload that you're operating today. Think of an application that maybe you're building. Maybe you're a product manager, maybe you're a developer, maybe you're a program owner, and there are workloads that you're responsible for, either supporting or owning or building. And then ask yourself that question, how well do you understand the internal state of that system? How well do you understand the health of that workload? And you may want to think of, what do I have to measure the health? Right? So we have things like logs and metrics. All of those can be things that we can call output signals, such as an external output. So a log, a metric, or a trace. Events, all of those things can be known as external outputs, something that system's outputting that we can use to measure it. Think of a system input potentially as what is some sort of behavior that happens on a system that makes some sort of impact, right? Some sort of stimuli, meaning maybe a user request, potentially a health check, maybe some sort of fault injection, or even something as simple as like a synthetic test. Any of these things are impacts that could impact the system, and then we could then measure from those output signals. But really, what makes observability, you want to think of it as a property of a system. So observability is a property of the workload, just like other properties. Right? Highly available, fault tolerant, scalable, loosely coupled, and lastly, observable. Meaning that our application, our workloads, have things that make them observable or do not make them observable. Meaning, do we have the right output signals to properly evaluate the health of an application you're running? Think of, let's say, maybe a mission critical workload. Is that workload emitting the right output signals for you to properly evaluate the health? Do you have the right KPIs defined? Do you have the right metrics defined? Are you looking at the right logs? These are all things that you need to be able to think of, specifically when supporting these larger scale applications. Now, like we mentioned, observability is a property of a workload. So there are things that make that workload observable. It's an adjective, so it is or is not observable, whereas monitoring is the act of taking data from an observable system and then determining its health and performance. So that's the verb, right? We monitor an observable system. So really, when we think about it that way, monitoring and observability is pretty simple, right? Observability is what makes the system observable, and then monitoring is actually just the act of taking all of that data and then determining the health, performance, SLAs of our system. Now, you may ask, Why is all of this really important? And if you've ever been in operations, or if you've ever supported one of these mission critical workloads, put yourselves in the shoes of potentially a DevOps engineer or maybe an SRE who's potentially getting paged later at night, or a system operator that's getting paged because some sort of system's down. Having these observable systems in place is what is really going to matter when it comes down to mean time to resolve. A system that doesn't have these properties, it's going to take much longer to figure out what's happening and then identify, pinpoint, and resolve that issue. So for applications where uptime matters, reliability matters, resilience matters, observability is critically important. Now, earlier we spoke about some of the foundation components of observability, specifically those output signals, right? So we have first metrics. Metrics are really great for determining those key performance indicators or KPIs, as well as establishing a service level objective on those KPIs, determining what type of performance level do we want to have. Metrics are really great because they act as a time series. They allow us to react in response to events, meaning if CPU gets too high, for example, we can alarm on it, take response to that event. Or maybe if we're running a web application that's doing e-commerce and we see the order rate go down, we could alarm on that. Let's take a look at just basic health checks. If those start failing, those are metrics. We can start alarming on those. So metrics are really great for being able to alarm. We can do metrics on time series. On this time series data, we can use static thresholds, such as like CPUs over 80%. We could also look at types of anomaly detection. So if our metrics fall above or below an expected value, we can start alarming on those. The next pillar we have is logs. So logs obviously are a really rich source of information. Using logs, you're normally able to pinpoint an event, and most times when looking at any type of operational event that you've been a part of, more often than not, looking at the logs is what is going to tell you what the root cause of that issue was. Once you pinpoint where the component is, normally pulling the logs is going to let us know what the problem was. And then lastly, but definitely not least, is traces. So trace data, distributed tracing. Where this is really popular and where it can be very useful is in distributed or microservice type systems, specifically architectures or workloads where you may be using ephemeral components or components that can be disjointed across many different loosely coupled types of compute or types of storage. In this case, what the traces allow us to do is they can give us a service map. So we can see all the different nodes in our application. We can see where there are bottlenecks. We can see where there are performance problems, where we see error rates. And if we take all of these pieces together, so metrics, logs, and traces, and then start correlating them, that's one of the key components of observability. Because now that we have all these output signals, we have them in a place where we can look at all of them in a correlated fashion, meaning that when there's some sort of problem with our application, I can go view a service map that's composed of trace data to easily pinpoint where specific applications are failing. I can see which component failed, which components are giving me the highest latency. I can dive right in there. I can view metrics for that component. And then I can also view correlated logs for those underlying resources. And that's really where the value add comes in for observability, or at least one of them. Now, earlier I mentioned, why is observability important? Why is it important to make sure our applications, our workloads are instrumented to produce these types of outputs, mostly being logs, metrics, and trace data? The first one we spoke to was lowering business risk. Mission critical applications need observability. I can't think of any argument why you would say a mission critical application does not need to be observable. Every mission critical app, or even production app for the most part, does need some level of observability. Now, another part of this is looking at being able to create new revenue streams. And what that allows us to do is, and the idea behind this is taking observability and moving it further to the left in your development cycle. And by that, what we mean is adding observability tools in earlier, which allow you to make product and development-driven decisions based off of user inputs. So you're able to iterate more quickly on your software and software development, which potentially is going to allow you to build new revenue streams. And then Lastly, but once again, definitely not least, is improving operational and financial efficiency. And that's going to be the topic for today. Now, when we speak about improving operational and financial efficiency, what we mean by that is really it comes down to a single question or we can almost distill it down to a single question of the resources that I have, how well am I using them? So when we think of financial efficiency, you want to make sure that what you're using efficiently. Operational efficiency really comes down to making sure that we are correctly leveraging our operational tools as well. Now, when we pass it off to Justin here in a moment, Justin's going to walk us through how the Amazon Alexa team started leveraging these observability tools specifically to help with financial efficiency. Because there's a lot that really can go into this topic, and what we want to think of is not just observability through the lens of reliability or through the lens of durability or uptime. We also want to think of observability as a means to improve our financial efficiency. And that's one of the key takeaways for this session. Now, with that said, I'm going to go ahead and pass it off to my colleague Justin, who's going to walk us through the journey that the Alexa team went through.
Thanks, Bobby. Let's talk about observability with Amazon Alexa. And before we do, take a moment to think, based on all the information that Bobby just gave us about what observability is, where are you in your journey? You might be very well built out and having great insights to drive your business, or maybe you're just getting started. Main point being, we're going to cover some topics today and have some ideas for you that will help you no matter where you are in this journey. So before we start talking about Alexa specifically, let's talk about what Alexa is. And the best way to do this is just to ask, Alexa, what are you?
Alexa is me. I'm a virtual assistant who can help you with lots of things, like timers and alarms, the weather forecast, the latest news and sports updates, as well as shopping lists and recipes. I can even tell you a joke. Just ask.
Sounds pretty cool. With all that functionality, there's a number of components we'll take a look at here in probably the most oversimplified diagram of how Alexa works in existence, but it should provide some context in terms of the challenges we face on our journey for operational observability. So when you ask Alexa to do something, so in this example, we're saying, hey, Alexa, play songs by ELO. The first thing that happens is on the devices, we have something we call wake word. These requests are initially looking for when Alexa is being invoked. And there's a number of different words you can configure to start a stream of Alexa functionality, but this functions locally on the device, not requiring an active connection. So once we have heard that someone wants to have an interaction with the Alexa product, we then go into our Alexa Cloud set of services. The first thing that happens in our automatic speech recognition components is to try and deduce what you said. So this happens across a number of different languages, dialects, accents, or in my household, 3 and 5-year-olds, which sometimes happens probably more accurately than I might like. But that's where we really try and take the audio and turn it into the specific words or requests that happen. Once you have the actual words from what someone spoke or requested, we get into our natural language understanding. And this is where we generalize it as, well, I now know what you said. What did you mean? What are you looking to do? What functionality can we serve for you? From there, we have a very complex world of routing to try and find the right functionality or application or a streaming request. And this is where we call in this diagram a speechlet. Think of it more of a piece of functionality that we're connecting a customer's request with. Once we connect all the pieces here, we're going to come back through our text-to-speech interface, and we can actually come back in this example. We end up saying we're playing songs by Electric Light Orchestra. Note that amongst this translation, the request came in for ELO, and we had to deduce that that actually likely meant Electric Light Orchestra, where we could then connect with the targeted streaming service to play this music. And I couldn't find a diagram for a dance party, but you can use your imagination. So all these pieces certainly are going to come with some challenges. for maintaining operational observability and efficiency at scale. As we look through a few of these, I want you to think, how might I be experiencing some similar challenges in my environment? First up, we have a large number of distributed resources and accounts. They're doing different things, they have different tasks, different needs, and having them work together certainly creates challenges in an operational space. We have fast-paced innovation. We're always looking to build new functionality, innovate, and deliver values to our customers. So some of the patterns we have, while we might get them optimized initially, it's important to reassess how they change over time. We do have highly variable infrastructure across teams too, whether you're doing machine learning, whether you're hosting services, doing other types of functionality being served up. There's a very large number of use cases and architecture patterns we have to make sure work together. And this all happens in a global collaboration model. With all these components, even in our simplified diagram, they do have to work together very closely and provide a great experience end to end. And of course, when you have components working together, they usually have very tightly coupled SLAs to have that overall experience come across as natural, efficient, and very useful. One of the unique parts about the Alexa ecosystem is there's a number of different entry points to interact with. It could be on our Echo devices, it could be a number of the other products or skills kits or embeddings and other products and services out there. So that just creates some additional variability we have to work with. So before we dig into some more of the details, what happens if I don't invest in operational observability? Well, on one hand, you kind of just go and build stuff, which is fun. We go and we build and we try and see if it works, and if it works, all things are great. But when something doesn't happen as you might expect, or we see some atypical behavior or SLAs increase, or we see budgets that kind of go through the roof, you really don't know why. And it's always best to be ahead of these trends or these outliers so you can keep your core business producing value as expected. So in Alexa, we generally group our operational observability into three primary pillars. And what we're trying to do is measure how efficiently we're investing in infrastructure that delivers real value to our customers. That first pillar is something we call cost attribution. This is the art of really seeing where our infrastructure spend is going. Like, what am I spending money on? And what am I really getting out of it? Trying to track, where those investments are as they relate to various programs, functionalities, and services is a critical baseline for understanding and optimizing your environment. Next, we look for some of those quick wins. Like, where do I have, we could call it waste, or where do I have resources that are underutilized? And we try and optimize those quicker wins, easy to find infrastructure spend that we could then recoup for investment elsewhere. The third pillar is functional efficiency. Once we've done some of our initial upfront attribution for where our money's going, and then we do some of our initial quick win optimization, we start looking at how we raise the bar on being efficient with the resources we are using. So, guiding principles, and if you ingest any slide we have in this content today, this will absolutely hit the high points. Where do I start, and what should I consider? Well, we find a lot of success with shared core operational frameworks. There's a number of different presentations and often references to the DevOps model employed across Alexa and thus Amazon. And this is a huge part of us being able to distribute and collaborate in a consistent way. And DevOps, for those that may not have seen, is really around owning the entire stack of a solution. It's typically in our environment, when you build functionality, you own it from its original development, creation, support, deployment, on up through the operational support. So it really keeps folks close to what they're building in its entire life cycle and can really help expedite taking action when things are noticed that need to be optimized. Next, we would highlight focusing on iterations over the mature state vision. It's very tempting to see something or take a look at a design pattern or reference architecture and say, yes, I want that. But it's important to note, while working backwards is very, very useful, you shouldn't try and go from zero to hero effectively overnight, and break it up into iterations that produce value along the way. We found a number of places where When we break things up into iteration, we look for incremental value, and oftentimes it helps pivot or influence your end state target environment and really helps you recoup some of that investment for building these operational observability tools along the way. Also, a guiding principle, take stock of what's available. You may not have to go and build as much as you might think out the gate. There's a ton of great tools, many of them available at no extra cost in the AWS environment. And taking stock of what's there and keeping an eye on the latest and greatest is a great way to get a sense for where you should be investing first, or where you should be making your next investment for understanding your operational observability components. So another one we talked about similar to DevOps is once you find a pattern that works, or once you find something that works well in your environment, consider automating that. And once you automate it, you can share it with teams and not have to have that redundant work distributed across a number of different groups. And anything you do can end up having a bigger impact than it would if everyone had to discover it themselves. Perhaps one of the most notable items here is reevaluate your operational trends always and often. So much can change in conditions, whether it's your external demand, customers, market conditions. Keep an eye on how those conditions impact what you're running and the value you're delivering, so you can make adjustments and make sure you're optimized for your environment as it evolves. Perhaps one of my favorite guiding principles is the fact that something doesn't have to be complicated or lengthy to build in order for it to be effective. One of the things we built 3 years ago in terms of going after idle compute resources, still running today, and it's basically a script that has a set of targeted accounts and environments, and it just runs from Lambda triggers, and it looks for something that's sitting there idle, and it'll scale it down. We started out very quick, shipped it, and an iteration of that is still alive today. Not fancy by any stretch, but it is incredibly effective at helping reduce some of our operational, call it underutilized resources. So as we jump into our Alexa journey, we're going to focus on operational observability with Amazon EC2. Now, everything we're going to talk about today isn't only for Amazon EC2. Much of what we're going to look at is very applicable to other services, but compute is one of the most common products in use today. So we're going to look at how Alexa went after these bullets for the guiding principles to provide some context of how you might be able to do the same in your environment. Starting with cost attribution. How many folks here have looked at an infrastructure bill and said, that's interesting, or whoa, was not expecting that? Well, sometimes with the right investments, your whoa, I wasn't expecting that can say, whoa, that's awesome. So really what we're talking about here is show me the money. Yes, I have always wanted to put that on a slide, and here it is, mission accomplished. But what we're looking for is, can I trace my customer priorities to my infrastructure investment? Where am I spending money? Why? What's driving it, as a real basis to understanding what's happening in my environment so I can then layer in on improving it. It's important to note that distributed teams should make decisions that fit their use case. We struggle with trying to say that here's a pattern of how we work, or these are the products we use, and really recognizing that different teams, different functionalities, different product portions really have their own unique needs. And to be able to segment those based on business groups or services is critical. There's a number of different ways to do that. We'll look at a few of them, but that's really helpful in understanding the different trends you have in your environment. Always worth highlighting provisioning options and billing models. There's a couple of things out there if we talk about savings plans, or if we talk about spot instances in the compute world. There's a number of ways with very low effort you can actually use the same amount of resources without paying as much. So before we even talk about getting more efficient and optimizing in the low level observability, there's ways to use exactly the same resources and to get them cheaper. So highly recommend looking into those items. Perhaps one of the most critical ones for us that we continue to work on our journey is resource cost allocation tagging. This is where you can really start to connect what's running with what it's doing and what I'm expecting to get out of it. Now, this could be tagging something as at an account level to say this account drives this service, or this account drives this business functionality, on down to specifically within an account, I provision these resources with a particular intent. And that becomes incredibly helpful when you start seeing trends or things that may be surprising, out of the ordinary. And absolutely, as we'll see when we look at trying to fine tune and be more efficient, the context is absolutely key in those examples. Of course, anytime we start capturing metadata and we've got some usage coming in, we can then start looking at trends and forecasting. What's happening? Is it what I expect? Am I being able to plot investment in one area with output in another? So this as a basis to bring some of that core context for your spend is essential for your kind of first step into your operational observability, in our opinion. So how do I do this? One of the most common ways, and if you haven't yet worked with the AWS Cost and Usage Report, also referred to as the CUR in this particular presentation, this is a very common pattern with many different labs and reference architectures out there. Highly recommend if you haven't looked at it, but you can go in and set up a cost and usage report that has hundreds of different fields for every build line item for a given account. If you're using AWS organizations, this can be consolidated and aggregated across accounts. And very simply, you can have that drop into an S3 bucket. You can use Glue and then Athena with something like Amazon QuickSight and provide a number of different trends and visibilities and drill downs. It's a great pattern if you're just getting started, or perhaps if you've already gone down this route, there's a number of new creative things that we'll take a look at today that might really help you get to that next level of observability. This is a quick example of a general dashboard that can be built. This is from one of the labs, where you can see in this case, we're looking at month over month by particular invoice spend by group. So just an example, many different things you can do with this, but it's all about establishing that context of where is my money going? Show me the money. Where is my spend going? And once we've established some of the baseline, where is my money going? Let's start talking about how I can use it more efficiently. And the place we start in Alexa, where we went next, was managing underutilized resources, also referred to as baseline infrastructure optimization. And we'll talk about what that means. So the premise here is, where can I optimize resources when they're not delivering value? So before we even get into how efficient am I, or trying to find a specific utilization target for one of the products, we're looking for ways to try and generalize. Like, where do I have hot areas of spend that aren't actively producing value with no associated business reason for leaving, say, idle resources running? Some of the places we can look at here in this theme of where is the collection of quick wins? What can I do without significant investment or without trying to get extra complicated on measuring efficiency? Two of the biggest places to find some of those insights up front that could certainly influence your further deep dives into building mechanisms would be Compute Optimizer and Trusted Advisor. This is a quick screenshot of some of the insights and suggestions you can see from Compute Optimizer. We also want to call out that sometimes transforming the data as it exists really helps bring new value to your visualizations. And we're going to look at an example of something we've done in the EC2 space to help us classify where we have some of that underutilized resource spend landing. From here, once you have some of these metrics, you can automate some guardrails and cleanups. We talked about a quick script that just went and looked for resources that maybe it was a human-driven account that was spinning up some compute, doing some ML work or some data transformations, and then maybe they forgot to spin them back down. Well, being able to recognize and automate that ability to go and scale those hosts down can end up having a massive impact in savings and overall efficiency. And of course, one of my favorites, CloudWatch. CloudWatch is a gold mine for various metrics, insights, but being able to go and aggregate across accounts really brings new functionality and new capabilities for deriving your own custom metrics. And we will look at an example for that. But first, let's take a closer look at Compute Optimizer. Here we have an example of one of the top level summary pages for Compute Optimizer. We can see that it's telling us right there in the AWS console that we have a certain portion of under-provisioned hosts and over-provisioned hosts, with nice click drill downs into getting some more details of how we could better leverage these resources. If we click into some of these collections, the next screenshot here, we can see specific recommendations. Hey, your current instance type is this. Perhaps you can move to this other instance type for a cost savings without impacting your performance based on all this logic that's already built into the Compute Optimizer service. Pretty awesome, and a great place to start if you're looking to try and see where you might get the most return on jumping into this underutilized resource optimization space. Perhaps the most impactful for us in Alexa in recent times has been our investment in CloudWatch metric aggregation. So in this particular diagram, we have a summary of what we did to aggregate CloudWatch metric data across a number of different accounts. So we see here at the base, we're using AWS CloudFormation to deploy stacks to n number of accounts, where through Amazon EC2 metrics, we can take CloudWatch metric streams, run them through Kinesis Firehose with a schema that's managed by Glue into an aggregation account. So now that we have these distributed streams that we can manage centrally with stack deployments, we have this data landing in a single place where you can then take it and bring it into whatever data lake or BI environment that you have. And that's where you end up being able to do some of the very fun cross comparisons, joining on additional metadata, and connecting your business as a whole rather than individual accounts. So now that we have this data coming in, how do I operationalize it? Where can I use this CloudWatch data to identify quick wins? Well, one of the things we did in Alexa, once we had some of this CloudWatch data centralizing, is we derived an underutilized compute ratio for EC2. And what we were trying to do is look for areas that we had compute resources that weren't doing compute things. And looking at CPU utilization or some of the other utilization metrics, usually we're just a partial part of the equation. And we wanted to find a simpler way to identify those areas for deep dives and optimizations. So a UCR, or underutilized compute ratio, is what we went and built. So the first step in doing this is to set a CPU utilization threshold, or if you happen to be using GPUs and are writing metrics or using instance types that have those available, you set a threshold. So in our case, we have a number of places where we're using 5%. Basically saying, if you're below 5% in this utilization, you're considered underutilized. You may not technically be fully idle if there's some memory operations or other things going on, but we're setting that as, hey, this compute resource is underutilized because it's not doing compute intensive things. So perhaps it might need an instance type change. Maybe there's a part of a process that's running. Maybe it's data transfer. You would still be identifying with this ratio where you're paying for compute resources that aren't doing compute intensive operations. So once we've got this threshold, we can create a ratio overall of the underutilized units. So if you sum up times, if you've got 5-minute Amazon CloudWatch granular metric data, you can use that to compare against the total and get that very simple ratio. There is the equation itself in all of its glory. All of my college math professors are incredibly proud, I am sure, for this extremely complex yet very helpful tool for generalizing underutilized compute. From here, we're able to group by various metadata and tags. You can actually join if you have instance level details being brought into this UCR calculation. For EC2, you can join that back on the cost and usage report to get joins with cost allocation tags, and you can see generally more about what is driving these conditions of utilization. From here, you look for those areas that you can go and address. Maybe it's a particular service or a particular use case in your business that is less efficient than others. One of the things we did with this data is going after noticing when someone is not leveraging all of the GPUs on, say, a P316 extra large. Being able to highlight this general sort of waste or underutilized metric really helps you push toward a focus. But now that we can see where our money's going, we can see generally where we're underutilized with some of these products, in this case, compute. That isn't exactly the end of the story. We want to go from there and continue to raise the bar, and that is where we get into the topic of functional efficiency, which is generally classified as fine-tuning our operational environment. So what does this mean? Well, as this slide starts to talk about it, it might get a little philosophical, where we ask questions like, well, how efficient am I? Is it good enough? What does good mean? Well, this is where things get a little more complicated, and this is why we typically don't recommend starting at trying to pick a utilization target, say for compute. Start with the stuff that's maybe quick wins, using the easier to deliver, more general logic, and then iterate into something like functional efficiency. How do we do this? Well, we've talked a few times about establishing tags and custom metadata. It's critical when you try and go another level in efficiency optimization to understand what is being done. Your efficiency patterns may look different if you're doing machine learning model training versus if you're hosting an endpoint service or inference requests. And understanding in your data which of those is occurring is critical for being able to connect those dots and find out what you should change and what path is available to do so. From here, we can also talk about adding custom metrics. So one of the things we've done on the previous generation P-series GPUs is went and created some custom CloudWatch metrics to capture GPU utilization based on an AWS blog post. And that gives us a very critical insight into what's happening on GPU resources to then be able to inform some of our efficiency analysis, set up alarms, and really connect more context with what's running and why, so that we can then get into probably the most important one here is establishing functionally specific baselines. When we try and answer that question, what does good mean? What does efficient mean? When you have enough data to tell you what's happening and what you expect to happen from that particular usage, it really helps you measure, like, am I getting better? Am I getting worse? If I have a low utilization, there might be a reason. If I'm trying to basically am okay with spending opportunity cost to keep SLAs and responses lower. So main point being here is not having those be surprises and have data to keep on top of it as your environment changes. So of course, when we talk about efficiency, and I just mentioned SLAs, capacity often has a big impact in terms of how we're managing efficiency, especially when we have customer-facing endpoints and functionality involved. And we're going to look at an example of managing on-demand capacity reservations that can show how we connect some of these data sources for managing EC2. But it's important to note with your capacity demands, understanding that part of your efficiency, given that in some conditions, auto-scaling policies, for example, may not scale fast enough, or if you have a resource that you need to absolutely have available when you request it, there's definitely some levers to work through there. Of course, as anything, once you establish some measures and you establish some baseline, you got to benchmark, you got to iterate, and you got to improve. Iteration being key here because those conditions can change, and keeping an eye on what your definition of efficiency is as you continue to raise the bar is crucial. So let's take a closer look at the CloudWatch on-demand capacity reservation and what we did in Alexa to combine some of these sources we've been talking about in that bigger spirit of operational observability. What we're looking at here is a utilization trend for coming out of CloudWatch utilization metrics for on-demand capacity reservations. Those that have not used ODCRs before, it basically allows you to reserve for your account and however you decide to share them, capacity for exclusively for that account and those shared groups within it. And in this example, we have the darker blue represents the number of hosts of a given type that we're holding, and the light blue represents when we're actually using those hosts that are held. So when we plot this hourly over time, we can see, at least when we talk about underutilized resources, we can see how effectively we're using what we hold. But there's a couple of points here that need some further scrutiny. For example, why is there a drop here? It could be plenty fine that that's opportunity cost and it's worth holding that capacity even though we're not using it. But is it because my overall usage dropped? Or was there some challenges with targeting the held capacity that I have? There's a number of variables in play here. Similarly, when we see ourselves running at 100% relatively frequently, we probably want to raise this just to further add that guaranteed capacity for these particular use cases. Well, how much should I add? Where should I bring this level to get that level of SLA and manage that overall opportunity cost to fit my needs? And then, of course, once we did that in this example, Did something break? We saw a bit of a downturn, and in this particular set of data, I can't really tell if something went sideways, if we had overall demand changes, and it opened up more questions than it did answers to begin with. But a little bit of a spoiler alert, at this point in this example, we went and added additional logic from the cost and usage report, which we'll take a look at here in a moment, that really informed this data set on its own. So what we're going to look at is how can I extend the cost and usage report, referred to as CUR here, to derive an hourly time series visibility into concurrent EC2 footprint. So I've got held EC2 capacity. I want to see what my overall usage actually is against that held capacity. And this principle can be applied to a number of different products that show up in the CUR that have a time-based life cycle. But what I want to do is provide that context to the capacity that I'm holding to get a bigger complete picture of operational observability. How do we do this? Well, in the CUR, like we mentioned earlier, there are a few hundred fields of wonderful metadata for each line item. What we're looking at here is establishing a key. In this particular case, a key would be an instance ID along with the account that spun up that instance. And using this as a key, what we want to do is take the minimum start date and the maximum end date for that key, along with its core metadata, and find those into a subset of data. We talk about grouping by the CUR metadata. You can use anything in here that you want. In our particular case, we were looking to match the instance types and availability zones and other components of what we had in our held capacity graph. But it's important to note that there is a wealth of different ways you can group this data. But what we're ultimately trying to do is get to that time series. So what I've done so far is give me the basically beginning and the end of a given unique instance. And we're going to cross-join that on all dates and hours in a given date range. There's a number of different tables and databases out there that can do this. But what we're trying to do is insert a record for this particular key in our case it was hourly, every hour from the start to the end time. From there, we do need to note some of the edge cases like hibernation. If something were to turn off and turn back on, you can factor that into your logic if need be. But what we end up doing once we have this data set after the cross join is I can sum the distinct resource keys per hour. And when I do that, I get a wonderful looking hourly EC2 footprint approximation that looks like this. So we denote this as running instances by hour. And this tells me a lot just by itself, given my overall seasonality of the usage. But where it really gets fun is when I overlay that with the graph of the utilization we just saw. Look at this beautiful graph. So let's take a look at those points that we saw earlier. Again, this is where we ended up folding in this additional data set of actual concurrent capacity. When we revisit that first point, I can see that I was actually using quite a bit more than the capacity I was holding. So what this ended up being was some challenges in targeting the held capacity I had, and we were able to make some changes and minimize that gap between what we were using versus what we were holding to keep at 100% utilization as much as possible when your usage is actually above the amount you're holding. Next, when we scaled up, we were able to actually use that recent run rate of unique concurrent footprint to inform where we would scale. And even though the trend was solid, we saw that dip. And that drop in overall usage was real. It wasn't anything to do with something breaking as we might have thought before we had this context. But it's also important to note, take a look at how much closer together our orange and light blue are now. Once we changed via point number 1, our targeting logic, we're now having far less of these on-demand capacity reservations go as unutilized. Back to making those tweaks and really maximizing our ROI on these resources that we're spending. So at this point, we've talked about managing where our money is, being able to track what we're spending money on. We talked about going after some of those quick wins or removing those underutilized resources. And then in this example, we've shown how we can go a little deeper at looking at combining multiple data sets to be more functionally efficient at a granular level. What's next? Well, now we talk about putting it all together, overall infrastructure ROI observability. And this is where we can take these three pillars and make sure that we're delivering the overall intended value to our customers. So at a summary, one of the ways we do this is taking that cost and usage report data, combined with our CloudWatch insights for all the various efficiency items when we've been talking about EC2, and then overlay that with financials. Since so many businesses, obviously financials are important, how does what I'm running and how I'm running it correlate into running the core business that I'm trying to run and the values I'm attempting to produce? Of course, this is where we start to see the give and take between budget and SLA. In many cases, if you had unlimited budget and a well-architected stack, you could have quite a bit of SLA guarantees before you kind of get into diminishing returns. But managing and having visibility into where your spend is actually providing value against some of these targets is absolutely critical. Connecting full circle what I'm spending versus the value I'm getting and how efficiently I'm using resources within that. Of course, in this stack would be business health metrics. I'm looking at trends. There's threshold alarms. There's budget alerts going in, changing forecasts, keeping all these connected and understanding and correlating business events and actual business value delivered with the infrastructure that's driving it is absolutely critical. As always, I need to reassess and raise the bar because conditions change. And when we start looking at this aggregate component, we have even more moving pieces where automation of these observability components can really help you stay on top of and not be surprised by conditions that change. Let's take a look at an example of pulling this all together. So what we're going to do is we're going to combine trends for the actual usage and cost. We're going to bring in budgets and forecasts and see some examples of how we use CloudWatch to actually observe some inefficiencies, address them, and then prevent them from happening going forward. Enter this wonderful graph. And what this is, very quickly, we're looking at actual daily spend against the forecast and against a budget. So it's important to note one of the things we found very useful in Alexa, even though many different groups would use a monthly budgeting cycle or a monthly forecast cycle, we found it very useful to break up any of those monthly components into a daily portion. So you take the budget or the target for the month, break it up into a number of days, and then bring in your daily infrastructure. In this case, we're looking at EC2 spend against what that daily portion of the target might be. And what this really helps you do is create some KPIs and create some early warnings and some alarms. When something goes out of the norm, it can trigger a deep dive into understanding why and correcting what needs to be corrected. So let's take a look and see what this particular example can show us. So as the beginning of this trend started, we were on forecast, but we were over budget. So seeing this, we're able to launch a campaign and look for ways that we can reduce our overall spend run rate, but still keeping all of our SLAs and operational commitments in line. And you can see that that blue line came down being both below budget and below forecast, which is double thumbs up. We went along for a little bit, and then we ended up having an event where we went over budget and over forecast. So this triggered some time to go and look closer. We had some scaling that was based on some inefficient assumptions, and we kind of went a little beyond what we had forecasted before eventually peaking out at a pretty inefficient peak where we doubled down on our optimization efforts to go and correct the scaling behaviors and bring us back in line with where we expect to be. Now, the important part when we came back to restoring our target trends in this particular example is that we created new alarms. And new alarms were looking specifically for that collection of usage, tagging, metadata, underutilized compute, and those functional baselines we've been talking about, and can set basically that early warning signal. And if you look just beyond point number 4 there, this same condition or very similar happened just after this particular case had set up the new alarms. And note that that little blip, that lasted about a day before we were able to go in and make those changes. So this is kind of that all-in, full circle of using all these observational observability tools overlaying them with business KPIs, and seeing the value come and really help us manage and be efficient more overall as a business. But as always, it's day one in Alexa, and we're continuously seeking to raise the bar. We're always looking for new opportunities, always looking for additional tools. And perhaps on that note, Bobby, anything new you think we should be looking at?
Thank you, Justin. Now we're going to go ahead and speak about a recent release, which is custom dashboard widgets. And what these are widgets on CloudWatch dashboards that are backed by AWS Lambda functions. And what these functions allow you to do is essentially extend your dashboards to really be able to do essentially anything. We can call AWS APIs, we can load data from external sources, we can go ahead and make API calls on our behalf. So not just a describe API call, but we can actually start taking actions. A great example of this, and I think it really well aligns with part of our message today, is from being able to combine cost and usage data with your CloudWatch data. So now let's say with a custom dashboard widget, now what you're able to do is run an Athena query against a cost and usage report. And then the output of that report and the output of that query can now be displayed on your CloudWatch dashboards. There's a lot of very interesting things we can do now with custom widgets. And if you haven't checked them out already, I strongly suggest you do. Now, with that being said, there is a takeaway I want us all to think of when we leave this session today, and that is think of those applications that you're supporting today. Think of workloads that you're responsible for. Think of workloads that you're building. Wherever you are on your observability journey or wherever you are on your cloud journey, think of something that we spoke to in this session today and think, do we have that? Would it be valuable to have? Are there quick things we can do to improve our cost and performance efficiency by leveraging an observability tool? And with that, I do want to thank you for your time. And we'll go ahead and ask Alexa, how do you think we did?
Well done. I enjoyed it. But next time, let me do more of the talking if you want to really raise the bar. Bazinga!